we're going to find the volume of the solid whose base is the area bounded by f of x equals the square root of x, the x-axis, and the line x equals 9. Oh, and whose cross-sections perpendicular to the y-axis are rectangles with height 2. Okay, so first thing we're going to do is we're going to sketch our area. So this is the square root of x. We're talking about the x-axis right here, and the line x equals 9. Now we notice the cross sections are perpendicular to the y-axis. So the y-axis is over here, so that means we're drawing it this way. This is dy, and when we set up our integral, it's going to be with respect to dy. Now as soon as I see this y, I know that all of these have to be in terms of y. So f of x, that's y equals square root of f of y. Okay, check. X of 9, that's the same as saying g of y equals 9. And then this right here, this is y equals 0, because that's the equation of this line for the x-axis. So what I'm seeing is that I'm going from here where y equals 0 up to here where g of y equals 9 and f of y equals y squared. So y squared equals 9, y equals plus or minus 3. This is clearly a positive value for y, so this must be the point something comma 3. And now I've got to figure out what this is. I'm always going to do right minus left, so this is 9 minus y squared. However, let's see what we do with that. So these cross sections are rectangles with height 2, so I'm going to draw my little height here. We know that this distance is 9 minus y squared, and we know that this distance is 2. So the area of this base is just going to be 2 times this distance, 9 minus y squared. Where that's coming from, volume is start to stop, area of base times width. Don't mind that we're kind of using width in two different ways here. This is just the area of the base, length times width of a rectangle, and then this is our little dy, just like we normally do. So we've got that. Easiest just to use a calculator on it. 2, 9 minus y squared, comma y, comma 0, comma 3, or 36. So for our final one, let's find the volume of the solid whose base is the area between the x-axis, the y-axis, and the line 3y plus x equals 12, and whose cross sections perpendicular to the y-axis are equilateral triangles. So we start by drawing it. So I've got the x-axis and the y-axis. This should be 3y plus x, not 3y plus 7. And if you're not quite sure how to draw that line, you can either get y by itself or get x by itself, or you can just say when x is 0, so when x is 0, y is going to be 12 divided by 3, or 4, so I'm going to have the point 0, 4 up here. And when y is 0, x is clearly going to be 12, so I have the point 12, 0 down here. I can just draw my line right through that. This is the line. 3y plus x equals 12. So the area that we're looking at is going to be right here. Cross sections are perpendicular to the y-axis, so that means we've got a dy. We're going in the y direction, so we're going to have a starting y down here at 0, a stopping y up here at 4. So it was useful if we graphed this by plotting these 2 points. Otherwise, we just have to plug in and find them now. And we know that cross sections perpendicular equilateral triangles. So we're going to need this. We're dealing in terms of y, so that means everything should be a y. This should be 3y plus f of y equals 12. F of y equals 12 minus 3y. So to find this area, we're going to do the right side. So that's 12 minus 3y. And then we're going to subtract this, which is just the line x equals 0, or let's call it g of y equals 0. So this is 12 minus 3y equals 0, or just 12 minus 3y. Now, cross sections perpendicular to the y-axis are equilateral triangles. So we have a nice little formula that we should have just memorized for the area of an equilateral triangle. I'm going to set this up. If we look way back over here, the area of an equilateral triangle is root 3 over 4 s squared. We can see that our side is this 12 minus 3y. So I've got root 3 over 4 side squared 12 minus 3y. That will be Math 9, square root of 3 divided by 4, 12 minus 3 alpha y squared, variable is y, 0, 4. On some of the calculators, you're going to need to put this fraction, root 3 over 4, in parentheses. It doesn't hurt if you do it on the 83s, but on the 82s, I think you have to do it that way. And there we go.